Alrighty, everyone. I'm feeling more prepared today, so hopefully this goes more smoother. Someone get the graph out, because that's going to be the most important thing, because that's what we're going to do for trial number 3. We're going to take the pH every time we put 1 milliliter of base into the liquid. But first, we're going to take 10 milliliters of the acid and find the pH of that and do the inverse log again. FYI. Okay. So for unknown number 1, trial number 3, the starting, let's see, the acid. Okay, so for the initial volume of the HCl, it's 19.99. Okay.
9.9 or 9.8?
She said 9.9.
Okay.
Oh, you need them, huh? The whole reason. Do you guys not have anybody in your group? No. Did you get the graph done yesterday? Yeah. Oh my God. I did it yesterday, and then I just like. Who did you guys dump into one of their groups? No one. Oh, really? Yeah.
28 points.
It worked out. It worked out, right?
And then the other Gavin.
5. Mr. Jackson, can I
Yeah.
let's see what if this is like.
How many followers did you lose after yesterday?
I didn't lose
Disturbing
any.
time.
It's the same one.
Same one? Nice. All right, so we have 28 and 28.4. It's just above. I'm going to say 28.4. 39 or 40, right? You see how it's just above it? Yeah.
Yeah, okay, so 28.40. Okay, so for the initial volume of the base, it's 28.40. Okay. Okay. Who has the graph out? Will you unmute and say?
We all do. Like.
Yeah, we all have it up.
Yeah.
So we'll be like checking to make sure it's right.
Okay, the volume is down. And then for the, like, I know on the graph it says beginning of NaOH and end of NaOH. For that, he's just said to write the initial and final volume on it. So let me go ask just in case. I don't know if that's the initial and final volume of like the entire thing or after we take the 1 milliliter. I'm not sure. So let me go ask.
Last time you gave us 7.32.
Yes.
Did I put that in the right place? Like it's supposed to be 19.
So yeah, you won't know the end until the end.
Okay.
Now, here's the deal. For this trial, whenever you reach 7, are you doing the pH one, right?
Yeah.
So whenever you reach 7, that's when you end the NaOH here.
Okay.
But then you keep adding until you get that high end of the graph.
Okay, so whenever we reach 7, that's when
Yeah,
we.
whenever you see the color change, that's whenever you mark here.
Yeah, but
but you keep adding on the graph.
and we keep taking the pH
Yep.
too.
Yep.
Okay. Did you guys hear that?
Can you just repeat it? It was kind of like blanking out a little.
Okay,
I
so
thought it was 28.4.
it's 28.40. Yeah.
Yeah, okay.
So basically, when we get to the pH of 7, when I keep taking the pH of the acid and the base combined, that's when we write the final volume of the base, but we keep going to make the graph like curve. Does that make sense? So we keep adding it.
So do we have to like make a new graph on like the 4th page to like keep up with the data or no?
No, just keep adding the numbers into the graph on the document.
Okay.
Okay, so we're gonna take the pH of 10 milliliters of the acid, and you guys need to find the inverse log of that, so the H plus, or the molarity of the acid.
What was the amount you calculated for
Concentrations cancel out, so they're both one. And then it should be the molarity of the base divided by the volume of the
Okay, ready?
base. We don't know the volume.
So what was the original? So around
Yeah, how many times?
around 30. Okay.
We have the.
You put in the formula, you know the molarity of the base, you know the molarity of the acid.
Oh, that is the molarity, yeah.
It's a strong acid, so the molarity is equal to the hydrogen atom.
Okay, thank you.
And you know the volume of the acid is 10.
So, okay, yes, did you get that?
That's right.
Well, it's the molarity, yeah.
Okay, so is when we drain the 10 milliliters of the acid, is that the final volume, whatever we end up with? Okay. So for the final volume of the HCl, I just drained like exactly 10 milliliters. Or yeah, it's right on the 30. So the final volume of the acid is 30.00. Okay. So now we're going to take the pH of that.
9,077. Cool, that, 9.9077. Yeah, that's actually about what we got, like, milliliter wise. Mhm. Oh, what did you say, Gavin? Yeah, so do you have the graph pulled up? Yeah. 35. Is this the base? That's yes.
So Mr. Jackson, measure every one milliliter of the base until it turns.
I'm not sure.
Yeah. Let us know basically what we're trying to make is that graph. Once it turns blue, you'll go beyond though.
Oh,
Mr. Dawson, it won't stop
Won't stop what?
moving. Like
Yeah, we're gonna tell you.
0.97, 0.99.
Once we get.
And I don't know where to stop this last time. I think we kind of messed up.
6.96. We're done. 0.96.
0.96 is the pH of the acid.
Did you add the one time balloon?
Oh, no,
No, not yet.
So don't we use that number and then do like the 10 to the power of the negative 0.96?
Yes.
So
Okay.
once you keep adding OH.
Wait, I thought we wanted to find the pH level.
No, we already found the pH level. That's what we just did.
Yeah, but why do we need the concentration?
To find the final volume of the NaOH. 'Cause
Oh, so it's not like last time where we have a final. Okay.
it is like last time. We used the formula again.
No, you're fine.
Because when we do inverse log of the pH that finds the molarity of the acid.
You can't go lower than this line otherwise.
Yeah, we got it.
You guys? Okay.
It's like, we just did a 12 point whatever, and I was like, no, it's gotta be exactly that.
Oh, I got it. All right.
We would never not measure the
Okay,
acid.
yeah.
That'd be ridiculous.
1.08.
We had a different amount of that. Yeah, we had one to start with the result.
And we still add 4 drops of the phenolphthalein. Okay, and then we add 1 milliliter each of the base.
1 milliliter of the base, and then
Take the pH.
1 milliliter of the base, take the pH.
Okay,
And what did you determine? How many milliliters should it be?
we haven't. They haven't figured that
Somebody
out.
at home should be doing that?
I haven't heard. Hey, have you guys gotten the H plus yet?
Yes, but like, do we do 3 sig figs or just 2? Because like the
I don't think it matters.
Yeah, I did.
okay, we'll just stick with 2 then.
Okay,
I feel a little sluggish. but-
what was it? Can I know?
I'm nervous.
It was 0.11.
Okay.
I would do 3 because we've done 3 for everything else.
Yeah.
Okay, so it'd still be 0.11 though.
Okay. All right, and then you'll do the equation VB equals, like, you know what we did yesterday? Guys.
Yeah. I know.
Yeah.
Okay, will you tell me what you get for that, please?
Isn't it 0.13, right?
Yeah, it's 0.130, yep.
I got 23.54, but anybody else? What'd you guys get? Isn't it, you did 28.4 times 0.13 divided by 0.11, right?
I think you would, wait. No, you don't do 28.4 because you're not using, because that's what we're trying to find. So you use the final volume of the acid.
Molarity of the base is
Oh, we use the 19.99 and the 30.
You use the 30, just the 30, don't use the 19.9. Because we're trying to find the final volume of the base. So you would do molarity of the acid, which is 0.130 times the final volume of the acid, which is 30, times 1, divided by the molarity of the base, which we found, wait, no, sorry. The molarity of the acid is 0.11, and you divide it by the molarity of the base. Okay, so in the equation, we use the difference between the final volume and the initial volume of the acid. So 30.00 minus 19.99 is 10.01
Times 0.11
divided by
divided by
1.13.
I thought the molarity of the acid was 0.102.
No, that's the molarity of the acid from yesterday. We're in a whole different.
Oh.
Okay, so times 0.11 divided by 0.130. Okay.
It is the same acid, but you kind of go with what you get this time. Does that make sense, Margot?
Yeah, because we're adding stuff.
Yeah. Well, we tested it again. Maybe yesterday there was error in the pH meter. The cool thing is that we'll be able to figure it out because we know the molarity of the base. So we're assuming it's going to be, how many milliliters did you guys calculate it to be?
8.47.
8.47. How many milliliters have we been before? 9.8 and 9.9, right? So we're going to slow down at 8.47, but we're still going to check to see what time it turns blue.
Okay, ready? Does someone have their graph out? Because we're going to start doing 1 milliliter at a time. And
Okay, wait. So the 8.47 is the final volume, not the
No, it's just it's just around where we need to start looking for the final volume. It's near.
Oh, okay.
We find the final volume when there's a color change, and that's when we write it down and we find the difference.
Oh, okay.
So what's the pH level at 0?
At 0, it was 0.96. That's what we did before we added any base.
Okay, thank you.
Right? Hold on, let me ask, because we did that without the phenolphthalein.
You don't count that. You just, yeah, it's just in there and you start adding the base.
But if they're on the graph, it's milliliters, 0 milliliters.
Yep.
So we do it with that.
I mean, that would be considered 0 milliliters. So
Yeah.
you can just start adding the base now.
Oh,
And then
but
that'd
we
be
didn't
1
find the
milliliter.
pH of this yet.
But that, it should be the same as 0.
Oh. Okay.
The indicator shouldn't change it.
Oh, okay. So yeah, it's still for the pH of 0 or 0 milliliters. The pH is 0.96, what we found earlier. Okay. Okay, so 1 milliliter.
Yes, thank you.
You're welcome. So around like 29, a little past.
Mr. Jackson, I am not good at chemistry.
1.77.
You can't take the class, it's fun.
No,
It's not like you're worried about some GPA thing.
no, that's dumb. I'm not worried about college or anything.
We gotta do this fast.
Yeah, so should we, how many milliliters is it usually for this? Because we don't want to
And we don't have to wait too long.
Well, you can take the pH of it and see, right? You know the volume, or you know the yeah. But you're gonna take 10 milliliters of this acid still. It's the acid.
It was like 9.5. Yep.
Yeah, that's the acetic I get wrong, right?
Yeah.
Okay. For 1 milliliter, it's 1.09. Okay, number 2.
Ooh. See, excited chemistry. You should see what we do in AP. Could be way cooler than that.
We're about to go to 9. Oh.
Look at this, you get to make your own little crystals in AP, right? It'd be like something dangerous.
Should be like
Cyanide crystal, you have to make your own cyanide poisoning.
mercury.
1.01 for 2 milliliters. Oh. 1.11 for 2 milliliters. Okay.
What's that? 9.5. No, it isn't.
Oh, it's green now, right? That would be I would call it there because that's where the transition from yellow to green, or yellow to blue is when it turns green. There's yellow and blue maybe.
Green.
See?
Oh, yeah, so it's
Yellow and
it's just
blue.
colors. It's very colors.
It's all just colors.
Doesn't matter at all.
What I'm confused about is there's no 8.47 is all the way up here. Do I do the difference?
No. Yeah, it's the difference. So
Okay, so-
28, so it should be like 36 something, right?
Oh, you add it plus 8.47?
Yeah, because it goes down, right? Yeah.
1.18 is 3 milliliters.
Like on the graph.
No, it's because we have to remember.
I think we'll only go like 12 or whatever.
No, I'm saying the measurements. No, yeah.
Oh, no, hold on, it's still going up. It's still going. Keep watching. I know, it just turned to, it went from like yellow to just. 1.27.
1.27 for 4 milliliters.
And it keep going up. Yeah, well, tell us when the, when you see the graph start to look like all of you make the graph. No, it's not.
Is everyone good?
Yeah.
Okay.
If you want to see what we're doing, we've shared the graph with like both of you guys, so you guys can like pull it up if you want to.
Okay, thank you.
1.36.
For 5 milliliters, it's 1.36. Hold on, wait. Oh, wait. This is your computer. I forgot.
Did you want it to be a line graph or like a point graph? Because right now it's.
I don't know.
This is the graph he made, so like whatever way he put it, this is like the type of graph he wants.
Okay. I mean, you can also ask him later.
Actually, no, go, yeah, go to that. So do another.
So we're at 34 right now.
Mr. Jackson, what's the actual molarity for the unknown 2?
1.49.
Oh, sorry. 1.49 for 6 milliliters, right? I don't know. I'm losing track.
Oh, you guys ran out of base.
Yeah, it's 6 milliliters.
Okay, so 1.49. Okay, number 7. And right now we're like at 34 milliliters, so around 36.87. We should be seeing a color change, but that's just
Another milliliter. No, 15 milliliters. That's good to 11.
I don't know what we did wrong. We even put vinegar in here. We got 10 milliliters.
Check.
That's on
It's not getting to 7.
Did you guys find the polarity?
Because once the pH is at 7, then, well, I guess it's a really big change.
So that is when it first changed. That's when the reaction.
Okay, number 7, 7 milliliters, 1.66.
11.90.
Okay.
Watch for blue.
And then I'll give you guys the.
Yeah, do one more full
setting
milliliter.
on that
Molarity of it should be 0.8393. Yeah, that won't.
I put a value in with no y, so it would be higher because it was.
Don't worry, you'll do it tomorrow.
Oh.
Oh, should we just stop?
I gotta make a more concentrated base.
Well, I don't know how to do it. That's why.
No, it's saying like.
He's giving it.
1.94.
1.94 for 8 milliliters. What milliliter does that graph end on?
It goes all the way to 23.
To what? To 20?
23.
Okay. Did I say 1 point? What did I say again?
Wait, what were you saying?
1.84?
And
1.94. Okay, thank you.
So.
Yeah, that's fine. 2.20.
Okay, and then with 1 milliliter of base added, the pH is 1.10.
Oh, wait. Is that it?
I'll be right back.
Okay, it's starting to get blue when it like touches it, but it's not like fully blue yet. So, and we're at about like 37.15 milliliters. So it's a little past what we predicted, but it's okay.
He said just hold off.
I mean, this might have been the color change because
Really?
it went up.
Yeah, but it should be at 7.
does the pH need to get to 7 for like?
Yeah. So when it like officially turns blue, we're gonna take the pH and it should be around 7. Right now it's at like 4 something. So it went up a lot.
What?
4.97.
4.97 for, is that 9 milliliters?
Yes.
Okay, so 4.97.
We do the things.
Wait, did it?
Do the thing.
Yay.
Wait,
can I show them?
So we did the.
Okay, turn blue.
Um.
Yeah, we're gonna give you the I'm gonna try to give you the
So real quick, guys, I need to make a base for that because the base that we have is not powerful enough to neutralize that within one trial. So why don't you guys do your math real quick? It'll take me 10 minutes to make this.
Yeah, we need to find the malaria.
What math?
I know, I think our math is done, but we can just.
You have to find
The M1 MABA times.
Oh, yeah.
So we
You can find the molarity and then average it.
Yeah.
So.
Is that 11?
Wait.
Yeah, well, we've done that. I'll send you the pictures of that graph.
Okay. Well, did you have-
Okay, the next one is 11.29.
Yeah, that's what that will do is you can estimate that curve up to that.
Mr. Jackson.
The graph should like.
Nine.
Graph will be
Yeah. Okay. So what was it?
11.29.
Did you tell him?
I'm gonna
Okay.
give you the pH.
Okay, so I told Mr. Jackson it's weird that it didn't, like, we missed it. Like, it should have been at 7, but he said it's okay. So the graph should still estimate it. Okay, so now we keep going and we keep taking the meter just so we can fill up the graph. Okay.
Yeah, so he's gonna have to make this.
Oh wait, we need to take
Yeah, so it'll have more malaria.
But first we need to take the final volume of the base. So I think it's right at 38. Okay. It's right at 38. So 38.00 is the final volume of NaOH.
You said 38.00, correct?
Yes.
Okay, thank you.
Okay. So, and then to find what?
9.6
Where?
for the
Really? It's 28.40. Oh yeah, sorry. I don't know why I thought it was going to be like 4 point. Okay, so Peter and I both got for VB, which is 38.00 minus 28.40. We got 9.6.
I
I
got
got
that.
Okay, cool. All right, so now we're just going to keep taking milliliters and fill out the graph. I don't know how long we're going to go. I'll ask Mr. Jackson that, but
Wait, were we supposed to be writing on the trial 3 chart?
yeah, but I can send you it. It's okay.
Okay, okay, thank you.
Yeah, you're good. You were filling out the graph.
That's so cool. That's not like Braden. So you're totally this one means nothing because it was over 50. Oh, do you guys school then about? Just how much it takes to neutralize it?
I'm just kind of curious at this point. So the pH of the acid for O2
Till it levels out. The graph levels out. So it should level out like at 12 or something like that. Yeah.
11. Oh, 11.85.
Okay, so he said we should stop when the graph levels out. And he said it should be around like 12, like pH of 12. So you guys just let me know when it like levels out. Does that make sense?
Yeah.
Okay. What was it?
11.85.
And then the pH of, I've lost the milliliters, is 11.85.
The new base is ready almost, guys. So prepare.
Did you get that?
Yes, thank you.
Okay. All right. Has the graph leveled out yet?
Not really. It went 11.29, 11.85. I would get like at least one more to see if it
Okay.
leveled.
Okay.
Whoa, yeah, that's so hot, like crazy, right? Just from dissolving it, it's that hot. Wow. That volume was up there, but how much it's down there? That's where I was holding it. Yeah.
So, what's the,
You guys really need goggles for this because this is almost 1 molar. It's 0.95. So
what is?
you could lose an eye on this one, please.
I hate goggles.
12.04.
Okay. For that one, it's 12.04.
Yep, this is 0.95. You can find the hydrogen. You can take the pH of the meter.
Yeah, but is it the hydrogen?
Should we do another one?
That's the molarity of that?
Probably.
Okay.
No. No?
You have to do the.
We're just around 12, so it's okay.
The, get to the square root of that times the Ka of that. Look up the Ka of acetic acid. Remember that one weird formula? No, apparently not.
Kevin?
What's the acid dissociation constant for acetic acid?
There should be one more for 7.
The answer is 1.75 times 10 to the negative 5.
1.75 times 10 to the negative 5.
And what do we have to do with that?
Yeah.
That's it's that formula. The hydrogen ion concentration of a weak acid equals the molarity of the acid
Times the K. And then
times the Ka
Square
square root.
You're gonna need to show me.
Yeah. You're not taking the final, are you?
No, I'm not.
Yeah.
I haven't got enough. grades.
12.15.
Yeah.
12.15 for that next one.
I paid attention.
Yeah, I think you're good because it only went up like 0.11.
Okay. Alrighty. Should we? I'm scared. Should we do one more? I'm like,
If you want to.
okay, we'll just do one more. 'Cause I'm like nervous that.
Ka divided by. So you're gonna have to.
You see that water balloon flight after school?
Huh?
See that water balloon flight?
No. There's a water balloon.
The seniors are having a water balloon flight in the parking lot.
Oh my god. That's fun. I feel bad for them.
12.26.
Okay, 12.26.
And then for the NaOH, the initial one was 0.0.
So.
It increased by 0.11 again.
So not a lot.
No, it's increased by 0.11 the past 2 times.
Okay, is the graph like kind of?
The
Yeah.
graph is like leveling out, so like we're good.
Okay, we're good. All right, so we're
And-
good on that. Sorry.
I believe it should be like a line graph or like just points.
I think it should be a line graph. Okay, so new trial, rinse everything out, but we can keep those beakers. Will you rinse this stuff out?
Yeah.
Is this graph right? One of these? Like which one would you select?
Most people do it. Yep. There you go. Yep. That's the one.
Wait, which one?
Do that.
Okay.
This one.
I mean, it doesn't matter.
Okay, so.
All right, here we go, guys.
Line, I don't know how.
This is 0.950 molar.
Yeah, we don't need that.
Wait, what'd you say, Margot?
Concentrated base.
Can someone change it to be a line? Because I don't know how.
Oh, finally.
Is that the molarity of the
Hydrogen-
base?
That's the hydrogen ion concentration.
I can try to.
The epsilon is the negative pH, and that will give you this. Yep, I gave you the KA of 1.75.
Is this, wait, is this done or do you?
Sure.
Yep.
All right.
I haven't played that.
Okay. That was like either the base of the acid.
You know the 8 mark, right?
I'm sorry?
It'll be 8 plus
The
9.
the square root
And then we can get the base.
1.75
Wait, I think I messed with it. Does this look right?
That looks right, I think.
plus we have
So the hydrogen ion concentration
Oh,
of the
why does it peak?
that's equal to the square root of the molarity of the acid times the Ka. No.
Yes.
The Ka of this is 1.75.
That makes sense. Then you'll have everything you need to do. Yeah, we can do that one.
Okay, I'm gonna go get that.
Operator, are we getting our base?
Probably got enough time for one trial, so that base, if you have 10 milliliters of the acid, that base should be less than 10 milliliters, just to let you know.
Okay, is this the polarity or is this the final? Okay, I'll write it down here. Yeah. Okay. Now,
I'll put it back on.
the milliliters needed.
You can get it on your hand, did you?
Okay, this is the acid.
It looks good how it is, I think.
Raise your hand up, guys, yep. Make sure you got that.
Oh, I need goggles. Oh my god.
Oh, hold on, no, the H plus is not gonna be needed. Okay? Yep, you found the polarity. H plus is not gonna be.
Okay. This is for the base.
Yeah.
Don't forget, you're using phenolphthalein, not bromothymol blue for this indicator, right? So phenolphthalein, get your drops up here, and there's a couple bottles of it.
How much is
Same number, 4 drops.
Wait, what? Hold on,
Okay, we're probably gonna only get one trial done of this, so I'm just gonna put 10 milliliters into the, oh wait, I need to rinse the acid out first. Right?
Phenolphthalein, you got some,
Yes.
you guys got phenolphthalein over there, you guys got phenolphthalein on the top.
Yep,
Phenolphthalein.
50.8231. 32.
Dude, this sugar's so static.
We need a graph for this one too.
Yeah, we're probably not gonna be able to get the graph, because that's when you have to take the pH of everyone. So we're gonna do the graph tomorrow, because you only need to do one graph of each.
Yeah.
Okay.
Since this is the first trial, I'm gonna see how this goes.
You're pressuring us.
I want to teach 2 class systems of it, right? I gotta get more patrons. Libya's going to San Diego or wherever. Nicaragua?
Ecuador.
Ecuador.
So,
Yeah.
Yeah.
What were you doing that day?
I remember last year you were saying you were gonna move, but then you didn't. So I thought you were gonna move.
So,
That she was faking again, not this
I
time.
thought you-
basically,
COVID.
Yeah,
Did
everyone
COVID
thinks-
mess that up?
Everyone, yeah, everyone thinks I'm faking it, but
Why would you?
Not this time.
not this time. Well, because last year I actually thought I was.
Yeah, I remember that. That was sad.
Yeah, it was.
I remember a bunch of friends like crying in Miss Casey's class because they thought she was like a
Miss Casey's?
Oh my god. Okay.
Good
So,
job you did, dude.
he said
No, it's not the
Olivia, your Spanish is gonna get really good.
hopefully, and my college application is gonna be fire.
Yeah, true.
Don't screw this. Don't put on.
Okay, so we're gonna fill it up.
What were you saying, Gavin?
Wait,
No.
No, we didn't.
That's fair.
If you're not doing it for every trial, yeah, let's do that tomorrow.
Is
Tomorrow.
like that, it's gonna shove it under here, and then switch it to your-
You can.
I think we're gonna write it down. That's
And then you
essentially
can
what
have
we're
the
doing.
Let's not.
Let's not right now.
Let's not do much stuff.
No, seriously, not right now.
Okay.
get you.
Hold on.
Go, turn up the right stuff.
40.
I don't want to fill this up again.
No. You know, Thaling.
What did
you say?
Thaling.
It's gonna change colors to something.
Put that in.
So it's gonna change.
Hey guys.
Oh, yeah, right.
Whatever color.
You need to get more of this base and be really careful when you touch it. Or like when you touch the base. It's the really long bottle. Yeah. Yeah.
Numbers.
And don't get a lot of it. Get like less than 10 milliliters.
That's too pink. Yeah, you want it to barely be pink.
Well,
It needs a set, but yeah, you just want it to barely.
yeah.
Yeah, be careful. It jumps quick, right? Oh, too much. See?
Okay, that's the acid.
It's a first trial, right?
It's a road estimate for our.
Rough estimate for the first trial, that's fine. Yeah, I get
Just,
it.
the other two, for our first one, we got 9, the first one we got 11. Really good for the base, so it's really.
If it's too far away from your other two, you want to throw that one out as an outlier and just say that you screwed it up, right?
Yeah, that's what we're doing.
That's one of the cool things about, did you guys actually find how many milliliters it should have been? Using that square root thing, did somebody there find out how many milliliters it should have been?
Yes.
How many was it supposed to be? Huh?
15 milliliters for the base.
15. All right.
That's about like 42.
We just.
10 milliliters. This is clean, right?
Yeah.
Yeah, it's about time to go, guys.
Oh, really? Crap. We're not gonna finish.
Keep going.
Oh, no.
See what you can get.
Okay.
So.
Okay, so the starting amount of H2C3H, like the vinegar, is 40.00. And then the NaOH, what do you think that is? I have no idea.
42, 6, 7.
You can try to do, okay, you can try to do the thing again if you want. We got 10
So that's
milliliters.
And then the starting amount of NaOH is 42.99.
Like doing everything over again, but. Yeah, that's it. Okay, but let us know if you do something like this.
Or what, like, what are you doing?
Or the.
Double master.
You have everything else though, right?
What was it whenever you read it? 30 when you muscled. What was it? 30.
Hold on.
So 38.5, and now it's what? So we take 49.5 minus 38. You made it way more difficult.
Okay.
Other
So,
than this class is hard. You got extra math in.
or 51.11. Okay, so, and then the final volume of the acid is 51.11.
No, you're gonna use the same one because we do the law of averages.
Now we do 4 drops. Do we do 4 drops again?
Yeah, and you have to get the pH curve of that one too.
Do we do 4 drops again of phenolphthalein?
Yeah, it's the same. What?
4
4
drops.
4 drops. Yep. You guys are gonna get called out though. You're not gonna finish.
What's the actual?
No, I didn't take pH. So it doesn't change with the drops.
I think so. I'll look it up. I've got it right there. I have it on me right now.
2.27.
Okay, the pH of the acid is 2.27.
Yeah. Tomorrow we're looking for just smallest smidgen. I know. That's why I was like, we have big goals in here. We don't have just tiny little goals.
These 2 bowls are too big for me.
We have huge goals. I mean, this is the pink that you might wear out on a Friday night. We're looking more like an Easter Sunday dress.
That would be
Like that.
No, this is like.
No?
I'm sad.
Okay, so for H plus, I got 0.0054.
Good.
1 second, Raylan, or Ramaya. I don't know who's talking.
On this track. So I am giving you guys 2.5%.
Wait, 2.5%, what is that?
Whatever your grade is now.
Plus 2.5%.
Wait, who?
Yes. Wait, 2.5%.
The,
Joy. Oh yeah, that means you're gonna get a C.
Ouch.
Yes, that means I'm gonna have
I mean, like, color her out.
No, oh yeah.
Yeah. Oh, that'd be, yeah, that'd be.
Well, she.
Let's do the day.
No,
Wait, Peter, watch
Well,
it.
it's funny to make Taylor see the lie, it's okay.
No. I made these all the way back.
Whatever, you looked it up.
Whoa, that's so cool.
Who made that for you? Did you make it?
Riley.
No, Riley.
I don't know,
Still doesn't stay though. Mr. Jackson, it's not staying pink. It's just hanging out.
It's gonna be like.
Danny, oh, you're too low. This is a fault. You can't do it because you can't measure it. So it's not worth it. It's okay. Deep breath. We got time tomorrow.
I don't have time tomorrow.
Why not? You're not coming?
No, I'm coming, but how are we gonna get 3 trials done and a graph?
Because you're gonna be amazing.
Oh.
Yep.
No,
Hey guys, have a great day.
Bye.
what was that, Michael?
Thank you.
Bye. Thank you. Bye.
Look at that, all the thank yous and byes.
Yeah.
That's a good group. We'll just-
Yeah.